The company has applications that run on Amazon EC2 instances in a VPC. One of the applications needs to call the Amazon S3 API to store and read objects. Okay, according to the company's security regulations, no traffic from the applications is allowed to travel across the internet. Which solution will this meet this requirement? When you hear this, yeah, an EC2 instance inside a VPC needs to talk to an Amazon S3 API, and traffic should not leave the internet. Just use a configure an S3 gateway endpoint. That is actually the answer. We're good. Okay, question 92. Company is storing sensitive user information in Amazon S3 bucket. The company wants to provide. Oh, I didn't say why. S3 gateway endpoint just basically make sure that you're using the AWS internal network. You're not leaving for the internet. Yeah, so it's using the VPC. It goes to the S3 using internal AWS network. It doesn't. The traffic doesn't leave the internet. Let's see question 92. Company is storing sensitive user information in an S3 bucket. Company wants to provide secure access to this bucket from the application tier running on Amazon EC2 instances inside a VPC. Okay, which combination of steps should a solutions architect take to accomplish this? Sensitive information in S3 bucket. Company wants to provide secure access to this bucket from the application tier running on this. Okay, so A is configure gateway S3 gateway endpoint for Amazon S3 using within the VPC. A is correct. Now create a bucket policies to make objects in the S3 public. That doesn't make it secure. Create an IAM user with S3 access policy and copy the IAM credentials to the EC2 instance. Then create a NAT instance and have EC2 instance use the NAT instance to access the S3 bucket. That is insecure. So I can say create an IAM user with an S3 access policy and copy the IAM credentials to the EC2 instance. Does that make any sense? No, that doesn't make any sense. C is create a bucket policy that limits access to only the application tier running in the VP. Yep, so I go for A and C. That makes sense. A and C definitely makes sense for me. Don't know why I was even thinking about such bullshit. Okay, 93. Company runs on on-premise application that is powered by MySQL database. Company is migrating the application to AWS to increase application elasticity and availability. Okay, good. Current architecture shows heavy read activity on the DB during times of normal ops. Every 4 hours, the company's dev team pulls a full export of the production DB to populate database. Oh, okay. Pulls an export of production to populate database in staging environment. During this period, users experience unacceptable latency. The dev team is unable to use the staging environment until the procedure completes. A solutions architect might recommend a replacement architecture that alleviates the latency issue. The architecture also must give development team the ability to continue using staging environment without delay. Which of this helps? Okay, so I can start thinking of things before going to the answer. The company is migrating to K. Current architecture shows heavy read activity on the database during normal times of ops. So the first thing is heavy reads is obviously create a read replica so that reads are only done on the read replica and writes can be done. That way it's going to alleviate. Every 4 hours, the company development team pulls a full export of production database to populate a database in the staging environment. Yeah. So a database in the staging environment. So we can also, if we have staging environment, we can also have a read replica in the staging environment. Yeah. In the staging environment, we have a read replica in the staging environment and a write replica. So that when you're pulling data from the production environment, when you're exporting data from the read replica of the production to and writing it to the to the master of the staging environment. that's me thinking way too much. Let's see. Number 1, use Aurora MySQL with multi-AZ Aurora replicas for production. Populate the staging database by implementing a backup and restore process that uses MySQL dump. Okay. Populate the staging database by implementing a backup and restore that uses MySQL dump utility. Okay. Backup. Okay, let's see. Backup and restore. Okay, use Aurora with multi-LZ or Aurora replicas for production. That's okay. Use database cloning to create the staging database on demand. Create the staging. Cloning to create staging, okay, on demand. Backup looks a little too long. If you can clone this on demand, that makes sense. Now use RDS for MySQL with RDS for MySQL with multi-LZ deployment and read replicas for production. Use standby instance for the staging database. Okay, and then use RDS. Okay. Use Amazon RDS for MySQL with multi-LZ deployment and read replicas for production. Populate the staging database by implementing a backup and restore. So backup and restore MySQL dump doesn't seem like a good idea because it's going to take time. I'm going to go with the cloning, but so like I'm going to, let's say, use Aurora MySQL with, I'm going to go with B. For production, use database cloning. I'm going to go with B. That is the answer that I pick. Cloning is instant. Yes, that sounds about like my answer. What is the correct answer? They say it's B. Okay, I guess so. Let's see question 94. Company is designing an application where users upload small files into S3. After user uploads a file, the file required one-time simple processing to transform the data and save the data in JSON format. So transform, that is ETL. So we'll probably need ETL. I'm not sure. So something like AWS Glue already comes to mind. Each file must be processed as quickly as possible after it is uploaded. Yeah. Demand will vary. On some days, users will upload a high number of files. On other days, users will upload few files. Which solution meets this requirement with least operational overhead? Okay. So if we're not going to use, do we have anything Glue in the comment section? Okay, so configure EMR to read text file from Amazon S3. Okay, let's see. So EMR uploads a file. The file requires one-time simple processing to transform data and save data in JSON format. So Elastic MapReduce to read text file. Run processing script to transform the data. Store the resulting JSON file in Amazon Aurora DB cluster. No. Configure Amazon to send an event notification to an SQS queue. Use EC2 instances to read the queue and process the data, and then store the JSON there. Configure S3 to send an event notification to Amazon SQS queue. Use the AWS Lambda function to read from the queue and process the data. Store the resulting JSON file in DynamoDB and configure event bridge to send an event to kinetic data streams when the new file is uploaded. Use the AWS Lambda function to consume event from the stream and process the data, and store the resulting JSON file in an Amazon Aurora DB cluster. We look for least operational overhead. D has so many things going on. So configure Amazon EMR to read text file from S3. Run processing script to transform the data. Store the resulting data. Okay. Resulting JSON file in an Amazon Aurora DB cluster. Let's see, JSON file. Okay, least operational overhead. Configure S3 to send event to SQS. Do we need an SQS in this particular? Elastic MapReduce to read text from files from an Amazon S3. Okay, so user uploads a file. Okay, one-time simple processing. Okay, I'll go with ping. Hapo now nimeshindwa. This place hapo I'm tripping. So let's see. So they say that's what you see. EMR. I'm not sure what EMR. Elastic MapReduce reduce EMR to read text files. Okay. Configure S3 to send a notification to an SQS. Use Lambda functions to read from the queue. Okay. So configure S3 to send event to to queue. Then use Lambda to read the queue and process the data, and then store the data in Amazon S3. Okay. That makes a lot of sense. Yeah, that makes a lot of sense. EMR AWS EMR. Data pricing job, machine learning queries. Okay, yeah, true. EMR doesn't read data from an S3 bucket. Yeah, I kind of did forget elastic mapping reduce what it actually does. So that comes to, you configure S3 to send an event notification to SQ to a queue. Then the Lambda will pull that message from the queue, will pull, and then it will read from it, and then it will process data, then store the JSON in DynamoDB. Perfect. An application allows a users at a company headquarters to access product data. The product data is stored in an Amazon RDS MySQL DB instance. An application users at a company headquarters. Product data is stored in RDS MySQL DB. The operations team has isolated an application performance slowdown and wants to separate read traffic from write. A solutions architect needs to optimize application performance quickly. What should the solutions architect do? So when you see read and write, then you should just get a read replica. Then all read data can be directed to all read data will be to the endpoint, to the read endpoint, and then write data will be to the cluster. So create read replicas for the database, configure read replicas with the same compute and storage size as the source database. Okay, so change existing database to multi-AZ deployment. Serve the read request from the primary availability zone. That sounds like a high availability. Change the existing database to multi-AZ deployment. Serve the request from the secondary availability zone. Okay. Create read replicas for the database. Configure the read replicas with half of the compute and storage resources as the source database. Okay, so our solutions architect needs to optimize the application performance quickly. Okay, in that case, why are we considering, okay, create read replicas for the database? Yeah, D. Read replicas should have the same compute and storage as the database. D is the correct answer. This is supposed to be, why are you halving stuff? So that is the answer. Amazon EC2 admin created the following policy with an ARM group containing several users. So version statement. Effect is to allow, action is terminate EC2 instances. Resources, action is terminate resource all. Condition, IP address is equals to AWS source IP. Terminate instances, okay, here. So effect is deny, action EC2 resource all, string not equals. What is the effect of this policy? Okay, so effect is allow, terminate instances, resource all. Condition, IP address, source IP is 10.100/ for that CIDR. Effect deny EC2. So this one is denying everything. Resources, everything. String not equals EC2 region. Oh, okay. So there are two different sides. So this is to deny anything, denying all action if string is not. So everything that is not US East 1 should not allow. So users can terminate an EC2 instance in any region except US East 1. So it says what is the effect of, okay, so this is deny all actions. So deny all actions if you're not used. So string not equals, so effect string not equals, string equals, if string is not equals to US East 1, deny. So if string is not equals to US 1, so users can terminate an EC2 instance in any AWS region. Okay, effect allow. Okay, users can terminate an EC2 instance with an IP address this in the US East 1 region. US East 1 region. Okay. Users can terminate EC2 instances in the US East 1 region when they, okay, so this is two. US users can terminate an EC2 instance in the US East 1 region on the user's source IP is this. Okay, I'm tripping. Users cannot terminate an EC2 instance in US East 1 region. So effect is deny. Effect is deny. Action is EC2. So this, if it is not equal to this, so deny. So deny. Effect is deny. Action. So this. So we deny EC2, all EC2 action. We deny all EC2 action if it is not EC2 instance. So if string is equal to US, okay, so it means if you're on EC2, you will get if string not equals, deny if string is not equals. Okay, so users cannot terminate an EC2 instance. No, users cannot terminate an EC2 instance. Users cannot terminate. No, users cannot terminate. Just deny. So this is deny. Deny all EC2 on US East 1. So here is allow. So users allow EC2 instances terminate source IP. God damn it. Users can terminate an EC2 instance in the US East 1 region when the user source IP is 10.this. I guess.